protection of OH and its deprotection. So, functional protection of OH functional group and its deprotection, how it is carried out. So, first is the ether. Ether, most of the times we use a functional group protection for OH is ether. So, what is the general formula of ether is ROR. Yes. So, this R and this O comes from alcohol. So R is any alkene or alkene. Okay. So the preparation of this one can be written like this: ROH plus R dash halide means alkyl halide. It contains of base, solvent. What it gives? This is ROR dash. This R dash is come from the alkyl halide, whereas this RO is come from alcohol. Got it? So, what are the properties of this ether? So, we must understand the properties of ether. We know that this ether is a very stable. Under what conditions? It is stable under acidic condition, second basic condition, third one is the oxidation condition, and the fourth one reduction condition. If it is like this, it is stable in acidic condition, this ether, stable in basic condition, or in oxidation as well as reduction condition. Then the question arises. What is the question arises? How we can deprotect it? If it is stable in these such conditions, so how we can deprotect it? The question is there. So deprotection of these particular ether to get respective alcohol, that is ROR dash to ROH. Here is a deprotection. What is a deprotection? So we must know the condition under which it is getting deprotected. So what is the condition to get deprotected? The condition is acidic. Sometimes basic also there. But now here we are focusing only on acidic condition. What is that acidic condition? Just now I said that it is stable in acidic condition, and now I am here, it is saying that it can be deprotected in acidic condition. But this acidic condition should be strongly acidic. we must have to remove this functional group. So that removal of functional group is called deprotection. So while carrying out deprotection, as I mentioned before, we should use a strong acidic condition, and that condition is PBr3. This is the strong acidic reagent which can cleave anisole into respective phenol, and this is the protection of phenol with methyl ether and then back to the phenol. So this is a protection of methyl ether. If you see the mechanism of this one, how is the mechanism of this one? Take this, suppose this ROH plus base, suppose NaOH, right? Then what it forms? RO minus Na plus, right? Then methyl iodide to get RO. This is the mechanism, we can say, or the pathway of the reaction. Sometimes they ask, write the pathway of the reaction. Sometimes they will ask, write down the mechanism of the reaction. So don't get confused with mechanism as well as the pathway. Both words have the same meaning. So consider a glucose molecule. So what is the glucose structure? Everywhere it is a secondary alcohol, and this alcohol, primary alcohol, is already protected with some protein group. Okay, write that OR. When you carried out methylation of this compound using methyl iodide in presence of silver oxide, yes, then all secondary alcohols got protected with OMe, means methylated all secondary alcohol to give respective methyl ether. So this is about the methyl ether. Now you move to benzyl ether. So what is the reaction will be the benzyl ether, or sometimes it's called benzyl ether. So for benzylation reaction, we must have benzyl halide. That may be benzyl chloride, benzyl bromide, or benzyl. But most of the times benzyl bromide is used. Next to that, benzyl chloride is used. So notation for benzyl is a Bm. Once again I am telling you, don't confuse with Bn and Bz. We'll say later on Bz part, but now we focus on the benzyl part. In the benzyl, this is the notation for benzyl. Bn is the notation for benzyl. Now you see ROH, this is one of the alcohol you take. Then add benzyl halide, then some base, you get ROBN. Means this is a benzylated ether. What is this? Benzylated ether. Once you have benzylated ether, we must know the properties of this benzylated ether. What are the properties of benzylated ether? As I mentioned before, it is stable under acid But how? It should be hydrogenated under palladium carbon condition. What is the condition? Under palladium hydrogen condition, this can be glued to respective alcohol, and this is about protection of alcohol with benzyl chloride to get the respective benzyl ether, and then on deprotection that is carried out under hydrogen over palladium and carbon, we get the respective alcohol. Just now, this is the general example we have seen. So we must move to the particular example, and this particular example is take this phenol again. Okay, then take a base like sodium hydride, then benzyl bromide. This is a benzyl, don't confuse. This is a benzyl bromide, it is a short form of benzene. So we will get a benzyl ether, right? This benzyl ether, it is a quite stable, as I said, in acidic, basic and mild hydrogenation and oxidation reactions. So if you want to carry out deprotection of this one, we must use hydrogen over palladium carbon. This PDC is palladium over carbon. So what is meant by palladium over carbon? Because palladium is a metal which is adsorbed on the carbon surface. So that is a palladium over carbon, and under hydrogenation condition we will get a respective phenol. Okay, so this is about the benzylation of phenol to get a benzylated ether under these conditions. So is there anything else to deprotect this? Yes. Beyond this hydrogenation, there are some other conditions to deprotect. First one, we know that is H2O PDC, we have seen it. Second one is Raney nickel. Third one, sodium amalgam. These are the three conditions which we can apply for the deprotection of benzyl ether to get back phenol. So while moving to third one, that is the PMB ether. PMB, it is a very interesting protecting group, and most of the time people use this protecting group because it has advantages over the other functional group protecting reagent. Because PMB, first we understand what is mean by PMB. PMB, P indicates para, M indicates methoxy, benzyl, B for benzyl. Just now we have seen that benzyl protection. Benzyl protection is like this. But para-methoxybenzyl is just having OMe at its para position. Means para-methoxybenzyl protection. So para-methoxybenzyl protection of alcohol, the general reaction can be written like this: alcohol plus para-methoxy. It is also called, sorry for this one. So we are seeing about this one, protection of alcohol is for methoxybenzyl chloride. So in basic condition like sodium hydride, the solvent, sometimes non-protonated solvent, always we have to use a non-protonated solvent like a dichloromethane. So we will get a respective RO, PMG. So what is this PMB? PMB is a 4-methoxybenzyl group, and this is called the PMB ether. Ether of respective alcohol. Right? So this is about the protection of alcohol using PMB chloride. Now we will see the exact example of PMB protection. So take this phenol again, right? Then sodium hydride as a base, benzyl chloride or bromide in dichloromethane or THF as a solvent. Then what you will get? You will get this PMB ether. Yes, this is a. Then we must understand the stability of this PMB ether. The stability is acidic condition, basic condition, reduction condition, oxidation condition. This is stable in all. Then how we can deprotect this? This we have to focus on. So for the deprotection of this benzyl ether to respective alcohol is carried out using DDQ or steric ammonium nitrate. These are the two mild oxidizing agents which can remove the PMB from this PMB ether to get respective alcohol. So then we must understand what is the structure of DDQ. How is the structure of DDQ? DDQ, dichlorodicyanoquinone. Steric ammonium nitrate, you knew it, everybody. So no need to explain that one. This benzyl ether means PMB protected ether can get back to phenol, which is carried out with the help of DDQ as well as steric ammonium nitrate. Now next move to benzyloxymethyl ether. Now move to benzyloxymethyl ether. The benzyloxymethyl ether is a bomb. Don't confuse. Not it is a Bank of Maharashtra, it is not a Bombay. It is a benzyloxymethyl as a protecting group. So just write down the structure of this one first. Benzoxymethyl means here is the C. So for writing this as a protection, then how we can write this? This is alcohol ROH, then warm chloride and base and solvent also. Then what happens? Then get use RO ether of benzyloxymethyl alcohol. Here the base is used mild base and solvent is not good. That is what aprotic solvent. Then we will get that one. Now CH2OH. Take this alcohol. This is IPA. And take this one. Diisopropylethylamine. What is this? Diisopropylethylamine. Base is a THF. Then what we will get? Isopropyl. Right? Is there any other example? Yes, it is there. What is that example? We must consider the other example also. In that example, we have to take aromatic compound like phenol, then benzyloxy methyl chloride, or that is also written as bomb chloride, one and the same. In diisopropylethylamine and THF, what we will get? So what is the advantage of this one over